Hi everyone, we're going to make a big step in this section towards dealing with quadratics that are not necessarily factorable. So I'm going to start with another trick for solving quadratics, and we'll build on that a little bit, and then we'll work on graphing as well. I'd like to start with a fairly simple example, x squared equals 9. Our goal is to solve, and the idea here is going to be that we will use inverse operations. So if x is being squared, to remove a square, we would square root both sides, which would give me x equals 3. And this is great thinking, and this is true. But I would like to point out that we're actually missing something. It's also true that negative 3 squared is equal to 9, so negative 3 should also be an answer. And this leads us to what's called the square root property, and that says if x squared is equal to some number, then x is equal to plus or minus the square root of that number. So this is really important. The square root is the key detail. If you notice, generally when we solve by factoring, we get two solutions. It is possible to only get one, but we're expecting that there's at least a chance that we're going to get two. If you forget that plus or minus, you've completely lost the ability to find that second solution. So this is the key detail for this section, that you can square root both sides of an equation in the same way that you can multiply, divide, add, subtract, as long as you do it to both sides. But square rooting comes with a little bit of extra trickiness, and that is that there could be a positive or negative number that you would need to square, and you have to give both possibilities. Okay, the next one is equally simple. I just wanted to point out that it's completely fine if you're not working with a perfect square for your answer to have a square root in it. So plus or minus square root of 50 is excellent. There are ways to simplify roots a little to make that number underneath a little smaller. I don't care about those at all right now. If you catch a problem on the homework that seems like it's asking you to simplify the root, tell me. I've tried to check for all of those, but sometimes I miss it on randomization. But plus or minus root 50 is great, and if you're asked to list those separately, you may actually be looking for y equals the square root of 50, comma, negative square root of 50. So that might be how you have to input some of your answers. The idea here is going to be reverse order of operation. So we need to apply the opposite operation in the opposite order. So sometimes people get a little stumped on where to go first, or I don't even know if they're stumped. I think they just jump in and grab the wrong thing. So if you need to, you find yourself doing that, just pause and take a break and say, okay, well, what if I plugged a number in here? Say I plugged in 1. The first thing you would do is add 1. Inside the parentheses is first in our PEMDAS. The next thing you would do is apply your exponent, then multiplication, division, and last you would do the plus 10. Which means the first thing we need to get rid of is the plus 10. This strategy will work anytime your variable only appears one time in the equation. If that's true, you can do this reverse order of operations thing. It's a really good tool. So I subtract 10 from both sides, and I get 2 times p plus 1 squared equals negative 18. And I can divide both sides by 2. P plus 1 squared equals negative 9. And next I would square root both sides, so I would say p plus 1 equals plus or minus the square root of negative 9. But I have a problem here, and this can happen. This is not possible. If you're studying imaginary numbers, then we could go further with this, but we are not. We're only looking at real numbers, so we do not take square roots of negative numbers. So as soon as you notice that, you can say no solution. And we know this is true. Quadratics don't always have answers, or I think I've mentioned it anyways. I'm telling you now, they don't always have solutions. So you might find 2 answers, you might find 1 answer, you might find no answers. It's even possible to get infinitely many solutions, but that's kind of a silly, weird case. All right, let's tackle 1 more. Oh, 2 more. We have about the same order of operations happening here, so my first step will be to subtract 1. And I'll get negative 4 times 3 minus 2w squared is equal to negative 8. And the negative 8 is making me a little nervous, but notice the next thing to go is the negative 4. If we divide both sides by negative 4, we get 3 minus 2w squared equals 2. And that is totally fine for our square rooting. So our next step will be square root both sides of the equation. Do not forget your plus or minus. Because that's not a perfect square, I'll just quit there. That's great. Now that I've gotten rid of the square and I didn't end up with a negative underneath, I can actually keep going on this one. So last thing happening here is adding the 3. So we need to subtract 3 from both sides. I'm going to just move up here. I get negative 2w equals plus or minus root 2 minus 3. It does not matter which order you write that. As we get into quadratic formula, you'll see that the way that's set up, the radical comes last, but it doesn't really matter. So whichever way you like it is fine. And then last we would divide by negative 2. So if you have a radical and it's not a perfect square, you're going to be stuck with something fairly messy, and just like this is fine, if you're asked to enter them separately, which I think you generally are, you'll type it in once with the positive root, and then do a comma, and type it in again with the negative root. Okay, very last thing is I just wanted to mention that we can solve literal equations with all these new tricks we're learning as well. So we're asked to solve this one for b. The first thing I'd like to get rid of is the 16a squared if I'm trying to solve for b. So b squared is equal to 9c squared minus 16a squared. And then I need to get rid of the squares, so I'll take the square root of both sides, and I get plus or minus the square root of 9c squared minus 16a squared. And again, that's a perfectly good answer. If you're working in context, in a word problems context, you might be able to decide whether the plus or minus are good answers and maybe throw one away, but here we would just leave it just like this. Okay, so that's solving with square roots. Thanks for watching.